Hello everyone, in this video we will solve some examples, literally examples in the lecture notes. Let's start with example 6.1. In this example, it is asked to determine dimensionless functional relationship for the pressure drop across the slider valve shown in the figure, so that we will write a relation for the pressure drop. So this pressure drop is the dependent variable and we will write it as a function of velocity, h, opening height, density, viscosity, and pipe diameter d. So those are our parameters. As you see, we have k equals 6. We have 6 different parameters. So we will write, we will make our dimension analysis in order to obtain 3 pi terms. And before saying 3, let's see our dimensional matrix ratio. Initially, let's obtain the dimension matrix so that we will see what is our matrix length. I will use MLT system, but you can as well use FLT system. We will obtain the same answer. We will write all for delta P, velocity, H, rho, mu, and d. Okay, we will write the dimensions for all parameters. Please note that dimension of pressure can be obtained from force over area, which is length square, and force can be obtained from m times acceleration, so that mass times acceleration is L over t square, L t to the minus 2 over L square, so that this is m to the power 1, L to the power minus 1, and t to the power minus 2. 1 minus 1 and minus 2. Velocity is L over t. H is just L. Rho is m over volume, mass over volume, or mass over length cube. For viscosity, we need to also derive if you are not sure. We know that shear stress, Newton's law of viscosity, shear stress equals viscosity times velocity gradient. Shear stress is also pressure, so that a pressure having m to the power 1 over L to the power minus 1 and t to the power minus 2 equals dimension of viscosity times velocity gradient has 1 over t as a dimension, so that from here dimension of viscosity will be easily m to the power 1, L to the power minus 1, and t to the power minus 1. M to the power 1, 1, L to the power minus 1 and T to the power minus 1. These again just L. So that as you see, we have M exists. There are some mass dimensions, there are some length dimensions, and T dimensions, so that R is equal to 3. This means that we have 3 primary dimensions exist in our problem. K equals 6, so that we will have K minus R, which equals 3 pi terms as a result of this operation. And R equals 3 also means that we need to select 3 repeating variables. How we will select those repeating variables? Initially, we cannot select delta P because that is dependent variable, but we need to use those 5 remaining parameters, and we have some rules. We cannot select H and D together, for example, because those are also forming a dimensionless variable. And we need to select one for geometric property, one for fluid property, and one for flow property. For geometry property, we can select either H or D. Let's select H, because it seems to be more important for this problem, this gap, comparing with the pipe diameter. For the fluid property, let's select density, because that is not very, viscosity seems to be not very much important. And besides, let's select V as the flow property, so that those 3 will be our repeating variable, and the remaining three non-repeating variables are just delta P, mu, and T. So that we will obtain 3 pi terms like those. Pi 1 will be delta P times H to the A1, V to the B1, and rho to the C1. Pi 2 will be mu times H to the A2, V to the B2, and rho to the C2. And the third pi term will be D times H to the A3, V to the B3, and rho to the C3. In this one, we have D and H together, so that without doing any computation, we can say that pi 3 will be equal to D over H. It is apparent that we can see that those two combination will create a dimensionless term, so that without making any computation, we can say this. For the other two, we need to do calculations, and just we need to equate the dimensions of left-hand side and right-hand side to be equal. For pi 1, for example, for this one, we know that on the left-hand side, we have m to the power 0, l to the power 0, and t to the power 0. But on the right-hand side, delta P is a pressure having a dimension of this, m to the power 1, L to the power minus 1, and T to the power minus 2. H has dimension of L to the power 1 to the power A1, and V has dimension of L to the power 1, T to the power minus 1 as a power of B2, and row has dimension of m to the power 1, L to the power minus 3, and has a power of C2. So that all m powers, L powers, and T powers should be equal. In other words, all those separately should be equal to 0. Let's go through with the power of m. On the left hand side we have 0. On the right hand side we have m to the power 1. And here m to the power minus. Those are all 1. B1 and C1. 1 plus C1, which gives us C1 equals minus 1. Let's go through with else. On the left hand side we have L to the power 0. On the right hand side we have minus 1 plus A1 plus B1 plus, or sorry, minus 3C1. Let's leave this here because we have more unknowns. And let's go through T first. For T, we have 0 on the left-hand side equals to minus 2. Here we have, and minus B2. This gives us, sorry, this is B1. B1. This gives us B1 equals minus 2. And inserting C1 and B1 here, we can solve for A1. Minus 1 plus A1 minus 2 plus 3 equals 0. This makes A1 equals 0. Which makes pi 1 equals to delta P times H to the power 0, V to the power minus 2, and rho to the power minus 1, which equals to delta P over rho V squared. Okay, this is our first pi term, and please note that we will solve for pi 2. Let's shift it like this. For pi 2, again, we will do similar thing. And afterwards, we will conclude the solution. Writing those for pi 2, please note that we have mu now. For the units of mu, it is a little bit mixed, but we can see it here. M to the power 1, L to the power minus 1, and T to the power minus 1 times mu times H to the power A2, L to the power 1 to the power A2 times V to the power B2, L to the power 1, T to the power minus 1 to the power B2 multiplied by rho to the power C2, M to the power 1, L to the power minus 3 to the power C2 equals M to the power 0, L to the power 0, T to the power 0. If you write for M, we have 1 plus C2 equals 0. From here, C2 equals minus 1. If you write for L, we have minus 1 plus A2 plus B2 minus 3C2 equals 0. Let's leave it for now. For t, we have -1 minus b2 equals 0, which gives us b2 equals -1. And inserting b2 and c2 here, -1 plus a2 -1 plus 3 equals 0 makes a2 equals -1. So that from here we can obtain pi2 equals mu times h to the power -1 times v to the power -1 and c to the power, which is rho to the power -1. So that P2 equals mu rho VH. Or if you can turn this, you will see that rho VH over mu, which is Reynolds number. That's it. We obtained 3 pi terms. We have this delta P over rho V square, Reynolds number, and previous, without making calculation, we obtain this one, d over h, so that we can formulate the solution like this. Delta P over rho V square can be written as a function of d over h and Reynolds number. That's it. Okay, let's leave this video here and we will continue with the next example.